Hey, greetings calculus students, how's it going? Pray you're doing well. We are wrapping things up rapidly, and I have so little time with this 15 minutes clock going, and I know that's about the y'all's attention span. Mine's probably more like 3 minutes, so you guys are better than me. So we're going to deal with the area and arc length, actually just area, and I'll do another video for arc length and polar coordinates. This is the formula. Again, look at your book. It does a good job. 1/2 the integral between alpha and beta. These are angles of f theta squared. So the function given theta squared multiplied by d theta. Or if you have the radius, this can simplify down to this. Okay. It looks very similar. I'm not going to go through how they got the derivation of this. They do a little bit of that in the book, but again, notice they look kind of similar in geometry. You have in rectangular geometry 1/2 theta r squared if you wanted the area of a sector between points A and B, all right, whatever this internal angle is in here. Or if a regular polygon, 1/2 A and S, if you remember from geometry, the apothem multiplied by the side length multiplied by the number of the sides. So, very similar. It's like, where do they even pull these numbers from? But the book does a decent job of going through the how this was acquired, but I need to jump right in. So I'm going to do work number 3, and in your book, which is r equals, I'll pause and set it up. Okay, so the instructions on number 3 is just find the equation. All right, don't even find the area. I'm not going to go through the whole process of find the area, but I do think it's important to kind of remember what we're doing. But here's the graph, and if you, in the book, it's shaded all on this side, so only this half here. So if we hit trace, all right, we need to go, what region is this going to be? So it's only going to be half this thing. You can do the whole thing, or you can do half of it. So you do half of the half, because there's a half here already for the whole equation. Okay, this is part of the equation. I go ahead and usually use the regions. Okay, now you could do the whole thing, and then split it in half, or you can go from here. So that's, what is that? I can't even see because of the glare. 1.57, okay, and then going this way, 1.57, and then we've got 4.71. This is where you have to remember those things in trig, like what in the world, 1.57? Oh, I remember that. That maybe was something. I'm trying to find my place here. Yeah, pi divided by 2, 1.57. And then 4.71, what? It's also kind of, oh, it looks like where it's at going to be on the graph. Oops, it's hard to line up here. That's going to be 3 pi over 2. So this goes from pi over 2 to 3 pi over 2. All right? So that's the region I'm going to do. This is all the book wanted for the answer, just set up the equation. But I'm not going to finish it completely, but I'm going to show more of the integral. Okay, so I wrote in here, you're going to be using your trig chart quite a bit. All right. So I didn't finish this out, but you know, you would have expanded that out, carry out the binomial squared, and then you have this using your parts of integration, breaking them into parts. So this, I didn't show all the work here, but 9 theta plus 12 cosine theta, because that was pretty easy. And then I have 4 times this, so I broke them into each of the 3 integrals. But then this, like, what? Okay, can't use a u substitution here. I have to use from back in the day, back in trigonometry, where we actually converted this into a double angle formula. This is in your appendix. I think it's number 48 or whatever. So I used the appendix here. So I broke it into that, and then I was able to take the integral of this, all right, and it breaks down into this part. And remember, we're taking a definite integral, and so, excuse me, at this point we would plug those values in and get area. Okay, but all the book wanted was this part right here. All right, we're going to carry on because I want to do one that's way more complicated and more fun. All right, this is number 21 in your book, and they're asking for the area between the loops of this equation. All right, I've got the graph going on here. Let me get out the glare. And what in the world do they mean between loops? Well, if you look at the previous problems, it says inner loop and then outer loop, and so, or inner loop. So if it's asked for inner loop, that would be here. Okay, but they're asking for the area between the loops. So it'd be the outer one, basically the big one minus this little one. So this is like a double problem here, because they want us to get this outer between the loops, so it'd be the big one minus the little one. Alright, so I'm going to go ahead and start with the little one. And in order to do the little one, no, I'll show you. Okay, so I decided to use trace here, and I've got 2.09 and then 3.14. So I know that's pi, and 2 point what? Okay, no, it's I can quit here. That's 2 pi over 3, 2.09. So I'm going to use 2 pi over 3. So this is going to be 2 pi over 3. Oops, let me write that up here. So going back to the graph here, I'm only going to do this bottom part underneath the graph and then double it to get the whole thing. So my equations, I'm doubling it multiplied by the 1/2. The original equation for it is 1/2, but I'm going to double it because I'm only doing a portion. So what is it? 2 pi over 3 and then to pi. Okay, I'm going to fill those in real quick. Okay, similar to the last problem, but right now this is just the inner loop, and I'm just going to find the area of the inner loop. Alright, that's my equation. Carried out that multiplication, then I've got this plus this plus this. Okay, this, no problem. That's, I'm going to distribute d theta to all of them. Alright, this one's no problem. That one's going to be a pretty easy one. This one again, this one's going to be a toughie. So this is on your trig sheets. Okay, it's down on the bottom. There's cosine squared and sine squared, but we're going to use a double angle formula here. So I'm going to substitute that into there. Took the 4 out with the 1/2. Took the 1/2 out as well. So that's just going to simplify to 2. Alright, and then I'm going to plug that in. So then I'm going to distribute the d theta to both terms and take integration of 2 more terms. Okay, I'm going to simplify all this. Okay, so down here we're working the integral, and boom, boom, and then distributing here, we get 2 theta out of this, and then again using got a u substitution here, let u be 2 theta, and then du is going to be 2 d theta. We've got to compensate for that 2 there, so we've got to multiply by 1/2 to compensate for the 2 here. You can't just put in a 2 just cause. 2 times 1/2 is still 1, so we're compensated for that. And then simplifying down, adding like terms, we're still taking the definite integral, so we have between the region of pi and 2 pi over 3. So plugging in pi and wherever we have a theta, and then plugging in 2 pi. This is going to be 4 pi over 3. Check your chart, and what is the sign of 4 pi over 3? That's negative radical 3 over 2. Adding like terms, simplifying, and then we get this. And that was just the inner loop. Okay, so now we're going to do the outer loop. I'm going to go boom and show all the work on the outer loop, and then we got one more problem to do. Okay. Okay, so now that I have the area of the inner loop, I need the area of the outer loop. I'm going to start at 0. 0 is always a great number. And then going down to the outer loop. Okay, right there. Hey, that's our happy number. We used that one already. So 2 pi over 3. So I'm going to go from 0 to 2 pi over 3. And then I'm going to double it because I only feel like doing it once. So I'm going to double it, multiply by 1/2, 0 to 2 pi over 3 of this same equation. We already did it, so we don't even have to do the integration again. It's the same one as we did previously, so no worries there. So yay, happy smile there. All right, and then we just plug using our trig chart, or if we remember the terms, carrying that out, and then just carrying out the math here, we get 4 pi. And then how do we get the area in between? Okay, remember, we wanted the area in between. We wanted this area out here, and excluding this one. So the area in between, so the area of the outer minus the area of the inner. So outer minus inner, and final answer is this, simplifying terms. Okay, all right, one more. Okay, so this last one, hopefully you have time, is going to find the common interior between this and this. Okay, so boom, there's the graph, and this one's a doozy. Okay, it's like some petals of some flowers that are blooming, and we've got this circle here. It's not quite looking like a circle, but it's because of the window I chose. But we want this region here. All right, hopefully it's pretty easy. We're going to do 1 and then multiply by 4 to get the other. So we only have to do this region and then multiply by 4. So So getting the other 3 is easy, but how in the world am I going to get this region here? Okay, well, we're interested in points of intersection. We've got to find points of intersection. And so we need to know that. Now I can hit trace and kind of see, okay, that's 0.26, okay, and I can come back around and look, okay, that's 1.3, but what? I could use as decimal approximates, but I want exact. So I'm going to find the points of intersection of those. Okay, so I just set the 2 equations equal to each other, just like algebra. Okay, sine divided by 2, and then I end up getting 2 theta using my, I basically let sine theta equals 1/2. So, or 2 theta equals this, and then I have to divide both by 2. So essentially I'm kind of like saying sine of A equals 1/2, and then A equals this, and then divide by 2. Okay? Okay, to do this, I'm going to go from 0 to, what was it, the other one, to 5 pi over 12. I'm going to go to there, and then I'm going to do that integral, and then I'm going to skip and go to the other equation and go from there to there, and then I'm going to go back to the other equation and then finish it out. Okay, so that's how I'm going to do that. There's a picture of what I'm talking about, kind of blown up. All right, so from 0 to pi over 12, I'm going to be on the on my calculator, the blue one, and I want this area. Okay, that's the area here. Then I'm going to switch to the other equations from pi over 12 to 5 pi over 12, and I'm going to get this region in between. Okay, so the region in between here. Okay, but if I cut from there to there, I'm going to go back to the blue line and get that one. So my formula is going to be this plus this plus this. Okay, I'm going to set that up. Okay, so the first one is from 0 to pi over 12, so 0 to pi over 12 using r, following the formula. Second one is from pi over 12 to 5 pi over 12, and with this equation here. Then finally the last one is from 5 pi over 12 to pi over 2 using that same equation. But because of symmetry, these two here are going to be the same. So I went ahead and just doubled this one. So I doubled this one, and then because of symmetry, the pink ones here are going to be the same. So rather than doing this one and this one, I just doubled it, knowing because of symmetry it's going to work out. Squared the 4 here, took out the 16 on the outside, so we're going to have 16, and then we've got this going on here, sine squared 2 theta d theta, and then this one here, 4, and took the 4 out, and then the 2 there. I'm like, what happened to my numbers? So there they went. Okay, I'm going to continue. Okay, so combining these two here, then u equals 2 theta, and du equals that. So, let's see, I get another 1/2 here. This becomes 1, get a 1/2 to compensate for this. Alright, and then I've got this. This one's really easy. I love these. These are nice. Okay. Then I went ahead and used my appendix here. You could do this, breaking it apart, but go ahead and go to your appendix, number 48, I think it is, and then it breaks it apart, following this, distributing, adding like terms, plugging it in, and then I'm just going to show. Now, this is the final answer here, but remember, this is just one. This right here is just that one leg. Remember, the original was several leaves. There's 4 leaves that went out. So we have to take this final answer, and I'll leave the work up so you can pause or whatnot. Get my pencil out of the way. And so this is, I'm going to put parentheses around it. Okay, so you understand, just distribute from multiply each term by 4. But again, I wasn't interested in getting a decimal approximate. I wanted to just show that we can use trigonometry. We can get exact answers with our trig chart, and there you go. But the key to this one was all the way back here, going in between the regions. So you're going to have some of these, and you have to kind of think about how the graph works between the regions. We're switching from, if this were f of x, I'm doing f of x from here. Then I switched over to g of x and did g of x from there, and then back to f of x and did f of x there. Got a few more seconds left, so I'm going to do another video of surface area, but that's about it. So God bless and have a great Easter. All right, bye. and he is risen. He is risen indeed.